Reacting monomers molecule to form a polymer molecule. So if you look at the screen, we are using Usman Aja's PowerPoint to discuss this. We are using Usman's PowerPoint to discuss this. We said the polymers are macromolecules built by linking together of large numbers of much smaller molecules, and the process of linking the repeating units is what we call polymerization. So we use his PowerPoint to explain this. Now we now said the monomers are small molecules which combine with each other to form polymer molecules, and therefore they are termed monomers. So if you look at it, this is styrene that I was telling you about. So styrene is a benzene ring that is attached to an ethene. A benzene ring that is attached to ethene. This is styrene. Can we all see it?
Yes, no. We can see it too.
Good.
Yeah.
Thank you. So that is it. That is styrene. Where the arrow is going through is styrene. Then when you process styrene to plenty styrene, is called polymer styrene. That is polystyrene. Now we now have other monomers. Monomers like ethene, which we treated yesterday under free radical polymerization. We talked about how we form polyethylene. So you see this is the monomer ethene, then the repeating unit is the monomer of ethene to form polyethylene. Same with polyvinyl chloride, then isobutylene and styrene. This styrene written here is a wrong styrene. Hope we know.
Okay.
Because the styrene here is supposed to have a benzene ring. Styrene always have benzene ring. Do you understand? What is there is cyclohexane. So we don't put cyclohexane as styrene. It is benzene ring that is what? Styrene. So the styrene here is wrong. Okay. Then we have prolatam. That is C6-diol. This is a common question in JUPEP where they ask you to write the Linus polylino. That is Linus C6-diene. So we will get to that. All those are examples of polymers. Then how big is a polymer? Polymer is very big. It's not something that you can. It's poly because it's macromolecules. Are you seeing it? It's macromolecules of that particular chain. Then we classify polymers depending on the structure, but we have not gotten to that yet. Instead, yesterday we talked about the two types of polymerization. We said we have the chain reaction polymerization, which is also called addition polymerization. Look at it here. Polymer structure, we have condensation polymerization, which is the same thing as the step. Then we have addition polymerization, which is the same thing as what? The chain. Are you seeing it? So the mechanism is called step polymerization, and for that of addition polymers is called chain polymerization. That is the structure that is here. This one, that types of polymers and polymerization. This is the structure. Are you seeing it? So down to types of polymerization, which we discussed yesterday, and we said the addition polymers are those that are formed without a loss of a small molecule. And I said it must have one functional reacting site. Like this ethene, the only functional group here is the double bond. We can see it here. So when the pi bond that is in the double bond is being broken to form a repeating unit of it, we will have a polymer. This is what we are talking about. I'm a little bit fast because it's just a recap. We are doing a recap of what we did on Friday. So condensation, we said condensation is that it will give us a small molecule, and that reaction is called the step reaction polymerization. So we stated the difference between the chain polymerization and the step. We said number one is that it involves one type of monomer with a single functional group, and while the step reaction involves more than one type of monomer. Then secondly, we said the chain reaction does not involve elimination of byproducts. That means it does not involve the loss of any byproduct. But for condensation, which is also step reaction, it involves the elimination of byproducts like HCl and water. So we went down to say that the chain reaction polymerization produces thermoplastics, while that of step produces thermosets. And we said the thermoplastic is a polymer that can be remolded after it is being applied, while thermoset is a polymer that cannot be remolded. That means it cannot be changed to another shape after it is applied. So we have about 7 or 8 differences between the step and the chain polymerization. Then we went ahead to talk about the free radical polymerization, that all these free radical falls under what? It falls under what? The chain reaction. That's what we said. We said it falls under chain reaction. That there are different types of chain reaction polymerization. Number one is free radical. So I think we stopped at free radical in that phase. So let me give a brief explanation of that free radical. We said free radical polymerization is the formation of what? A free radical as a building block. Many of you in your exam, they ask you what is free radical substitution. The point we want to see in that free radical definition is to tell us that free radical is formed or is generated. Are you seeing it? To form successive reaction or to form successive step of reaction. So, and in the free radical, the mechanism that is involved is number one, initiation. And I told you yesterday that the initiation is in 2 steps. And that initiation is number one is the first step of initiation is generation of the free radical. And we took note on that. We said for the generation of the free radical, UV light must be what? Present, or a very high temperature that will generate the radical. And we gave example of how radicals are being generated. So the reaction in this PowerPoint does not show the radical being formed. Does not show that radical is being formed. So don't ignore this point. Ignore this point, please, and take note of the ones we did on Saturday. So that will take us to this new topic where we are still working on the termination of the free radical. Are we okay?
No.
Yesterday, on Saturday, we stopped at termination step. We said termination step. Are we there?
Yes.
Termination step. Please, let me remind us of the instructions. Do not write on the whiteboard. Please don't write on the whiteboard. It is not for you. It's for me to write. It's where we are. We said is a radical chain growth. This is when the radical chain growth is stopped. Terminator step of the free radical is when the radical chain growth has what? Stopped. That is the termination step. And this step is involved in 3 ways. The step is involved in in 4 ways. This step is involved in 4 ways. Number one is combination of 2 active chain ends. Number one, the active end of a radical is a carbon atom with an unpaired electron. The active end of a radical is a carbon atom with an unpaired electrons. This can combine with another carbon with unpaired electrons to form polymer without a radical character. I will take that again. This can combine with another carbon with unpaired electron to form polymer without a radical character. So I want to give that reaction.
I'll take it again though.
Okay, listen. I said it's a choice. You are supposed to write. It's a choice if you want to write. But you are supposed to write, so remember the note.
Come again, please.
I said, please mute all of them. Okay. I said combination of two active chain ends. Combination of two active chain ends. Combination of two active chain ends. It's on there. It's on the board. Combination of two active chain ends. So if you have written that, I want to tell you what it means now. It means that the active end of a radical is a carbon atom with an unpaired electrons. Is a carbon atom with an unpaired electrons. This can combine with another carbon with unpaired electrons to form polymer. This can combine with another carbon with unpaired. So this is what we are saying. You know, we said that this is how to write a polymer. Write polymer like this. You see that sound? That alternating sound is called a repeating. It's called a repeating unit of that monomer. Now, so if you have two of them like that, that is two active sites. That is the meaning of two active sites. If you have the two of them like that, it means the radical will cancel each other. So if you have the two of them reacting, that is polymer radical. This is a polymer radical. This is also called a polymer. I'll be using short form. A polymer radical. PR, that's what I'll be using. Please take note of what I'll be using. PR as polymer radical. MR as what? Monomer radical. For the sake of this, so not that you're going to write it like that in your exam. No. For the sake of this online class, PR is a polymer radical. MR is a polymer what? Radical. So when the two react, character, that ethene will not longer be ethene, it will now be ethane, because the pi bond was broken for the radical to react. So you must put your bracket such a way that the bond will be outside. The bond of the H will be outside. Then this N means it's a polymer. Polymer is plenty. It's a large molecule of itself, of plenty monomer. So this becomes a polymer. That is, we call this one. This has to represent polyethylene. Polyethylene. So this is an example of polyethylene. This is how we form polyethylene. Nobody is expecting you to write plenty of ethylene. No. Instead, the N indicate the number, the large number of the polymer. Once you put N there, it means it's a polymer. It's plenty. It can be 10, it can be 20, it can be 100. Are you seeing it? But the one unit there, the monomer there is what? Ethylene, because we started with a double bond. So the radical breaks the double bond to form radical of itself to produce polymer what? Radical. And then we got this one. So the end product is called polyethylene. That is number one way of free radical. Then number two is combination of active chain, combination of active chain, and with an initiator. You know, we talked about initiator. With an initiator. So when we have that, how do you now indicate it in your reaction? You know, we initiated this. This is the active end. This is how we write the active end. C to C. Don't forget we are talking about polymerization of ethene. So if they are telling you to do polymerization of styrene, you follow the same process. This is the active end. Plus what? An initiator. We initiated with hydrogen radical. So that we end to stop the radical character. You can stop it with an initiator. So that is the initiator we put there. That stops that reaction. Chain end with an initiator. The radical chain can combine with another radical. The radical chain can combine with another radical to form a polymer with another radical to form a polymer without radical character. I'll take that for the last time. The radical chain can combine with another radical to form a polymer without radical character. So that initiator is the one that ends the radical. Like I explained to you before, I said when two radicals react together, the radical character will stop. Are you seeing it? It will go. So that number 3 now is interaction with impurities during the class. Please, okay. Didn't save now. Okay, we have the third form. The third form is interaction with impurities. That is the third way termination step can occur. Is interaction with impurities. Interaction with impurities. Yeah, impurities is any molecule. That is, we know what is impurity. Something that is not pure, that is not needed. So that impurities can be a radical, or it can be anything. can also be what? A radical, in which case the polymer is formed with a terminal impurity. So in that case, if the impurity is a molecule, then the radical character will be transmitted to a part of the impurity. But if the impurity is not a molecule, that is a radical, then there will not be any radical character at the end of the day. Number three is interaction. Please, I said don't draw on the board. Don't draw on the board, please. See now, they've already drawn on that board. How will we go to this one? With impurities. That is another way we can the notes now. When impurities are present, if the impurities are radical, then the polymer that is formed will be a terminal impurity. But if the impurity is a molecule, then the radical character, I will take that again. If the impurities are radical, then the polymer formed will be terminal impurity. If the impurities are radical, the polymer formed will be terminal impurity. But if the impurities are molecule, then radical character will be transmitted as part of the impurity. If the impurities are molecule, radical character will be transmitted as part of what? The impurities. Okay, if you are taking that, this is how the reaction will now be. We already know that when radical interact with radical, then polymer will be formed without radical interaction. But when it's a molecule, there will also be what? A radical interaction. This is the polymer, that is the active end. The polymer radical, you know there's a dot here. Those of us that don't know how to copy notes, copy it well in a way that there will be a dot showing that it's polymer radical. Plus a molecule. Let's assume the molecule is water. I told you before that P arrow, because this thing is online, P arrow is polymer radical. But don't write it like that in exam or in anywhere you see questions. P arrow means, for the sake of this note, P arrow means polymer radical. To produce, now if it's producing, it means it will produce a radical. Is that not it? It means it will produce a radical. Oh, sorry. You know the radical will end with H plus what? OH. In the note, the note is that if we have taken the note for number 3, so number 4. Number 4.
Divine.
Number 4 is chain transfer.
Clear.
That is not. Chain transfer
This one.
is number 4. Number 4 is chain transfer. So take down the note for chain transfer. Are we there?
Yes, ma.
The radical character can be transferred. The radical character can be transferred to from the polymer radical to another molecule which is capable of initiating polymerization process. The radical character can be transferred from a polymer radical to another molecule which is capable of initiating polymerization process. Full stop. Radical can be transferred to monomer, comma. Radical can be transferred to monomer, comma, polymer, comma, solvent or initiator. Polymer, the radical can be transferred to monomer, comma, polymer, comma, solvent and initiator or initiator. Solvent or initiator. So all these things we have done is to explain how a polymer is formed. How a polymer is formed using free radical polymerization. So if it is this one now is polymerization of ethylene, so it becomes polyethylene. All these things the example that we have done is polyethylene. Now what is free? If you have to do free position, free radical, that is the next topic now. Free radical Vine polymerization. Free radical Vine polymerization. Okay, I'm going to repeat the note for chain transfer for the last time. I said for chain transfer, the radical character can be transferred. The radical character can be transferred. Character can be transferred from the polymer radical to another molecule capable of initiating polymerization process. To another molecule capable of initiating polymerization process. To another molecule capable of initiating polymerization process. Full stop. And I said the radical can be transferred to monomer, comma. The radical can be transferred to monomer, polymer, solvent or initiator. The radical can be transferred to monomer, polymer, solvent or initiator. Now to the next topic, free radical Vine polymerization. They can ask you, what is free radical Vine polymerization? Because we already know that free radical occur in steps, so it means that since free radical occurs in steps, it means that the Vine polymerization will occur in steps, and the steps include the initiation, propagation and termination. Occurs in steps. So what is the Vine polymerization? When polymerization occurs at the double bond, write down, when polymerization occurs at the double bond present in any monomer molecule. When polymerization occurs at the double bond present in any monomer molecule. And this molecule can be in form of a substituted ethene molecule. This molecule can be in form of a substituted ethene molecule. So this is what I mean. Connected to H, you know this is ethene. Ethene is a double bond connected to H. So when we now say substituted, it means G is the substituted ethene molecule. So G there is known as, this G is equals to pendant. Many of us know what is pendant. Pendant group. It's not affect what is pendant there. Aspect pendant on the board. The spelling of pendant is on the board. Group. G is pendant group. So pendant group defines the monomer. Pendant groups defines the monomer. Pendant groups defines the monomer. Pendant group defines the monomer. Now, what is the polymerization? If you are asked what is Vine polymerization, this is what you now do. You will draw out the structure. C connected to double bond connected to C, H, G. G is the pendant group. So give, we said what will initiate it. What initiates it is UV light. So UV light is called an initiator. So this is the process of initiation. You initiate it with UV light to produce a radical. To produce a radical. So when you add it to the monomer again, there is another monomer. It will now be like this. To be in this form. then if you add more monomers to it, for example, you're adding monomer. Hope we know what is monomer. Monomer is what we gave on the board as the what? The 18, substituted 18 molecule. You add more monomers. The person put in a have indicated more monomers. It means we will attend to all questions later. When we come back from our break, we will attend to all questions. So this is the Vine polymerization. Now you see that there's no radical at the end of the product. There's no radical. So we call this one the polyvine polymerization. Polyvine. I think I should write that properly. Polyvine molecule. So let me explain this to you. So we will go for a break. We'll come back by 2 hours paper is not. So meanwhile, we said the polymer for polyvinyl chloride. The person that said we should take the note again. So please listen attentively. We are taking that note again, and we are using this reaction to explain the note. We said free radical Vine polymerization. Vine polymerization occurs at the double bond present in any monomer molecule. Vine polymerization occurs at the double bond present in any molecule. So we now say that the molecule can be in form of substituted ethene molecule. So if you look at the board, this is substituted ethene molecule. We say carbon connected to hydrogen, double bond, carbon to G. G there is the substituted molecule. Is that not it? So we call it Vine polymer. Now this G is called the pendant group. In polymerization, it's called the pendant what? Group. Meaning it depends on anything. It can be chlorine, it can be bromine, it can be iodine. So it's called pendant group. Now, what is the Vine polymerization? We now say that in substituted ethene molecule, the substituent is known as pendant group. Pendant group is what defines the monomer. So what is the reaction? This is the reaction below. This is the reaction below. This is the ethylene you see UV light. UV light is the one that initiates the molecule. UV light initiates the molecule. By the time the UV light initiates the molecule, a radical is produced. Are you seeing it? A radical is produced. So this is called polymer radical. This whole reaction here is called polymer radical. Then when this radical reacts with a monomer, that is the same monomer of its kind. So let me just give you the example. That is the same monomer. We know we are talking about chain. So chain is the same monomer. Chain is the same monomer. It was network that took us away. So now we are back. We said this is the monomer. UV initiates the radical, then a radical is formed. This radical, because there is an N here, we call it polymer radical. I said I will be indicating polymer radical with P dot arrow. So this because you will write polymer radical. Then this polymer radical reacts with the monomer. You know, chain polymerization, it must be the same monomer, the same active site. So that is why I'm trying to draw the structure again for some of us that didn't get it. So this monomer is this same structure. When we add the two structures, you see that we are added a radical combined with this. You see the bond here. The bond will come. We see C, this C that is here connected to two hydrogen.